My name is Omid. I work here at Wala. A few years ago, I got into the world of big data. A few months ago, I decided to start sharing this knowledge with everybody, whatever I did, at least the interesting use cases. So I started this meetup, and this is the fourth lecture, and today we are going to talk about the data governance. Feel free to ask any question, interrupt. This is more of a discussion than a lecture. Okay. So agenda, a little bit about the disclaimer. I am not a security expert, nor am I a network expert. This is not a lecture about network and security, but we are going to cover all the features in terms of network and security, because we're talking about the data context, about how to protect your data, what are your architectural options when you are starting a new big data project on the cloud, mainly on AWS. Part of this idea of this meetup was to simplify the process of knowing what to do when you start a new project. The previous lectures talked about this architecture, which I tried to keep as generic as possible and explain why I choose these technologies and not the other. They are mostly available at AWS, except the ClickSense, but the rest are AWS, yes. The agenda is to talk about all the possible consideration of your data, its access, its regulation, availability, which I called in a nutshell data governance, and what are the architecture implications when you start a new architecture. My advice for today, I assume that the audience is not a network expert nor a security expert, so try to keep things at very high level in terms of features and options, and try to ask questions if a certain jargon is not familiar with, or a technical term is not, you don't know what it means. The idea is to give a general overview and to talk about pros and cons. So as we discussed in previous lectures, there's many technologies in the ecosystem of AWS and the big data industry for on-prem as well. So I just took a short list of technologies out there, put this picture just to clarify how hard it is for a single person just to get started. And then on the previous lectures, as we discussed, we defined some high-level architecture where there are layers, there are 4 layers. The data collection or data ingestion, which either includes some PaaS elements, platform as a service, or you can write your own Java code or use open source project like Scoop. And then we put the data wherever it comes from, either from online elements or from on-prem, or either just an offline copy process to S3, which is the storage layer. And then from the data transformation layer, we use all these technologies to transform the data with a lot of flexibility and options in terms of data. And we discussed about the modeling, why we use these technologies and how we model and how we segregate the data and the technologies between the users, and how we visualize and why we use these technologies to visualize the data. But the main reason I put this slide, so we can talk about these layers of visualization, modeling, transformation, and collection We'll repeat this in the next slide, so it will be easy to remember that you have a section in your architecture that does specific things like ingesting data or transforming or modeling. Before I forget, like a quick note for everybody: if you're using new AWS accounts, even if it's a private account or a new account that you're just starting in a startup, or a new account in a new highly bigger organization, which new accounts pop every now and then, don't forget these quick notes. Disable unused regions for abuse purposes. Set the limit of the instances of what you are using. If you use 50 machines, then 50 machines it is. So if someone tries to launch 100 machines, you know you have a problem. And set the limit for what you're not using to 0. There are many defaults for many types of instances, so be sure to disable what you don't need and force anything you don't need to 0. And remove access key and secret key for root accounts. Sometimes it's easily forgotten. And avoid using the root account. I know it's tempting. Been there, done that. Not a good practice. Use it only. There are use cases where you can use the root account. There are extreme cases where you lose control over your bucket, for instance. You put a policy that says don't delete my bucket under any circumstances, even if you have admin privileges, and then you try to delete it after 2 years and chaval, as you say in Hebrew. MFA, the two-step authentication, use it. Okay, so for the purpose of this lecture, we'll talk about data governance. I did a quick search in Google, and I took the definition copy-paste from Wikipedia. And I highlighted what is important for us in this lecture: availability, usability, consistency, data integrity, data security, processes, blah, 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 enterprise, used by the entire organization. So this is the main purpose of this discussion. How do we use data? How do we secure it? How do we allow people to use it smartly? So we're going to talk about the data security level. Well, nobody likes it. I mean, in terms of architecture and developers, nobody likes to talk about security, but it's a big must nowadays. Simply because of regulation and the amount of security, cyber threats around the world, which are constantly increasing. Just a quick note about AWS, since this is a meetup and part of the context is AWS. Quick note, I'm not related to AWS officially in any way, but I'm just mostly familiar with AWS. So it's part of the process for a new project to show the CISO that the cloud provider you're using can comply with all these compliance lists. Each company has its own requirements. We didn't need anything other than PII and GDPR. Some people may require HIPAA and 27,000, and probably some 9,001 will be relevant, PCI, but what we needed is mostly this. Okay, so security, the options in general. I'm not going to cover everything. It's virtually impossible to cover everything in one lecture and make it high level and clear for everybody which are not security experts. Again, I'm not a security expert myself, but the cloud makes it easy. It makes it easy to get started because there are many platform as a service that enables you to do security basics, essentials, and keep it simple and work. So There are several things you need to discuss and several perspectives in secure. The first would be IAM, which is the Identity Access Management. The idea is to talk about users and their policies and groups, least privilege and MFA, which are the most common things you do with AAM. There are a lot of things you can do with AAM. But the idea is over there to define an AWS user, what is this user allowed to do, and to keep it to least privileges. Least privileges is a term that says the following. If Jorge over here is a BI expert and he needs access to Redshift and to S3, then this is only the permission he gets. If he's not using EMR, he doesn't get permission to EMR, and so on and so forth.
You can also define the roles, right?
You can define it in role, you can define it in users.
I mean, for example, if your server wants to get into some bucket, you won't use a user, you use a role.
Yes, this is a good remark from the audience about servers. You can use AWS user, but it's not a good practice. The recommended way is to use roles. I'll talk about it later, but it's a good remark. I didn't write it here. I can fix it for prosperity. Thank you for the remark. Roles is a better practice, yes, for many reasons, but we'll talk more about them. A quick note about least privileges. If you give Roy over there EMR permissions, which only states there are default policies by AWS. One of them is EMR read-only. You just gave him permission to change network settings. So if you give someone in the organization AWS policies, be sure to understand the details of that policies, okay? Especially the high-level ones like the AWS and EMR and so on and so forth. Another quick note about security is the key management service with another pass from which is accessible via IAM. It's a service that allows you to manage encryption either via server side or client side. We'll talk about it some more. We discussed about disabling data centers and unused instance families, limiting resources. We'll discuss. It happens in my computer as well. Swear to God, I didn't touch it. Account segregation, we'll talk about that. We also mentioned that as well in his lecture. Identity-based policies, yes. CloudTrail, which is AWS service that enables governance, compliance, auditing, and risk auditing. Bottom line, it's an automated tool that once you check the checkbox, it starts auditing whatever any user does in an account and keeps it in an AWS bucket. And you create a very detailed log of every transaction, including every read and write for every bucket in the account. And once you want to do something with that, God help you. But it's there. Okay? In case of a serious breach, this might be useful to reverse engineer or to understand what happened. Notice the costs, because the log can explode very quickly. So what I did as a ninja, I just put a lifecycle policy which enables you to keep data retention for as long as you want and not worry about the consequences of cost, because you limited to what you wanted. SLO resource management.
For how long you do that?
You talk to your CISO, Chief Information Security Officer, and he tells you that. Sometimes it's 1 month, sometimes it's 7 years.
Wow.
What? Wait, what was your comment?
I'm saying it depends on the industry, because I know in banking you need to preserve logs 7 years back and archive them, of course. But I think the default on AWS is 35 days retention period.
So we can, Jorge asked about data retention for auditing, and Roy provided gracefully his answer. It depends on the industry, from 35 days default in AWS to 7 years on banking.
I don't know if the AWS provides 7 years of banking. You can create on the AWS.
You can define, I think, the...
You can define it, but keeping the data itself in banking, at least once I was in the banking industry, it's 7 years to keep the logs available for governance and of course for security.
So 7 years for governance and banking. Okay, thank you for that. So back to resource management. Another perspective of security from AWS is to talk about policies from the perspective of the resource, or from the S3 bucket. So if Jorge had access to Redshift and he is trying to access a bucket, even if he has full permission on S3s, the bucket can deny access from Jorge simply because it's not his bucket. Okay? So you have policies that you can create are write only, read only, no delete. You can do some versioning. You can keep history of files like in Git. Every file you keep and you overwrite it, and then you have history. Be careful with that. You keep a lot of history, it builds up. You can change the encryption. You can add a checkbox that says default encryption and never worry about it again ever. We'll talk about encryption some more. You have lifecycle policies which helps you delete data which is unused after X days, and you can do it for specific path, and you can add some more rules, which is kind of nice. I used it a lot. Okay. So network options in general. So as my colleague Roy mentioned in his wonderful lecture, there's VPC, Virtual Private Cloud. Now we know what the C stands for. I might be mistaken. I don't know. It's VPC.
No, it is right.
He's right,
Yeah.
actually. What I did when I created our network at BU, which is the Big Data Project of AWS, we created a non-default VPC. When you create an account, you have a default VPC, and you can run with this, and life is hunky-dory, everything is cool. But if you really want to feel the insides of AWS and the power of AWS, and to understand a little bit about networking in the basic level, and your options in terms of big data, create your own VPC. It will take you a couple of days. It will be a headache. For non-network people, it will be a headache, but it will be worth your time for several aspects. One, if there's a major critical event in terms of network, you know your network inside out, so you can manage that. Second thing is all the possible use cases and how to protect your data. Meaning, one of the cases which we also mentioned, private network with a bastion host and a load balancer. Okay, so in terms of public subnet versus a private subnet. A public subnet is a subnet where the resources get a public IP. Even if it's not open to the world, in terms of security groups, it still has a public IP. So in theory, a hacker can get to it. So it's not a best practice to use public IP unless you have to. So hence you have a private subnet. So the same resource without a public subnet, and then you need some bastion host, which is, let's call it a metavech interprocessing a server in the middle that gives you access to the private server in the private subnet.
Proxy server.
Proxy server, yes, yes, thank you for that. I love my audience, thank you for that. So there are several use cases in terms of network. We'll discuss them soon. And I told you what I choose and why. You know me by now, I'm lazy. I have a small team, I don't want to work hard, but I need to be obligated in terms of security. VPC endpoints, cool feature that gives you the ability to do one thing. From your VPC, which we'll show in a diagram in a second, you can access your S3 bucket, but from the internal network of AWS, compared from the other option, which was before the VPC endpoints, was through the public internet. Secured, yes, but still through the public internet. Okay, so this is a cool feature. I think it was announced a year and a half ago, 2 years ago, something like that. There are endpoints for DynamoDB. And for S3, I think there are more by now. I only use the S3. NACLM, networks, access list, again, as Roy mentioned, security groups. We don't go into too deep into them, but I will say one thing. In the end of the day, NACLs and ACLs and security groups do one thing in the end. They either whitelist or blacklist a person or technology to access your network. So if you read all the best practices of AWS regarding VPC, and they are quite long and extensive, I will say in the end this thing. Treat NACLs as blacklist and treat security groups as whitelist. This will simplify your life in terms of management. I'm not saying anything else is wrong, I'm saying this is what I did. I read the manual and did it. VPC peering. VPC peering, as again Roy mentioned, cool lecture, you must see it. Go, it's a separate lecture, same channel. VPC peering is a new option. I think was announced 2 years ago, a year and a half ago, something like that. Is an option that enables you to take two VPCs and connect them via private network. This adds another option to your VPCs and some more degree of freedom and security. I think 6 months ago or a year ago, cross-region peering was announced, so you can do peering from VPC in Ireland, for instance, and Virginia, which was not available at first, but now it has. So it's a cool option to keep in mind. There are many architectures around peering. Look into that and see what matches your use case. You have a question?
Yeah, I was thinking VPC peering, if we're talking about cross-region, you pay for the transit, for data transfer between regions. This is costly.
Yes.
So this is something to keep in mind when you choose to peer two different regions.
Yes, a comment from the background and from the audience about cross-region peering. Sorry about the English. About costs and inter-region traffic costs. This lecture is less about costs, but this is an excellent comment. You should always be mindful about the cost of everything you do, and be sure to know everything you do costs money here. It's not cheap, but in terms of what you're trying to achieve, it's relatively simple and cost effective. Site to site. Okay, a quick note about that. It wasn't trivial for me, but I found out the hard way. If you do the advanced networking options with many VPCs for production and staging and cross accounts and segregation and whatever you do, and you end up with say 15 VPCs Sachbak needs to manage. And then your CISO says something like, well, where's my site-to-site VPN? I want VPN. So no problem, one click I make you, I will prepare a site-to-site VPN. But then I found out that this site-to-site VPN is indeed a managed service by AWS, but it's per VPC. So this changes a bit things, because now you have to maintain 15 if you have 15 VPCs, 15 site-to-site connections on your firewall, and again on AWS, it's 15 times the amount of cost. There's an architecture for that. For example, create a management VPC, create a site-to-site from the management, then from there do peering to whichever VPC you need. But again, you have to keep that in mind. So do some work, design your network across the board, show it to your CISO first, and then implement. Direct Connect versus HTTPS. Direct Connect is a cool feature by AWS, which is a known feature, but has a marketing name, so let's talk about it. Direct Connect is a feature that enables you to connect your data center, your on-prem data center, via a hard link all the way to your region. Ours in Ireland. We used it at first. It was a long setup, simply because all the carriers in the middle had to talk to each other. So long conferences, and this is not working, now it's not me, it's you, and so on and so forth. Had nothing to do with AWS, believe it or not, but all the intermediate carriers. And where the equipment we used was a bit old, so it was a big challenge, but we made it happen. The latency was quite low, about 80 milliseconds, which is impressive from here to Ireland, all the way to your private subnet. HTTPS, just be sure to understand that going through the public internet via HTTPS, yes, it's secure, but again, it's not secured as a hard wire from your data center all the way to your region. There's a cool feature known about later on in my work in, here in Walla, about protecting web services, web frontends. You have geolocation protection via the frontend. So if you use frontend and you don't have to expose it all over the world, it's geo protection. So quick note about CloudFront as well. You don't have to open the load balancer behind the CloudFront to the entire world. You can create a list of the IPs of CloudFront and open it only to them. But the downside is, if the IPs change, you need to maintain it. It doesn't happen every day, but it's accessible via AWS. You have to contact support and they will help you do that. But it's more secured. I did some detailed blog about some of the features in depth in terms of VPC and some examples. I took the highlights and I'm going to talk about them, but just to know for you guys, if someone wants to do some good reads and to understand all the options and the best practices, I think I did some summary, so you can do that. But I want to keep this high level, so we will discuss all the options in terms of a diagram. So I will take Rui's trick to keep you awake and start moving a little bit. Camera, I'm over here, thank you. So what we are talking here is an example that shows, I'll do it from here, it's easier. Don't know how you do it.
I had a louder voice.
Yeah, I had a loud, cool, calm, I'm super excited, so maybe in English, so it's a challenge. This diagram talks about direct connect. What you see here are two different regions, US West, US East. customer network, some AWS Direct Connect, which is hardwire all the way, not public internet as we discussed. And this goes here, then you can access all the way to your private subnets. Useful, has some costs. Keep that in mind. There's a 1 gig, I think, and a 10 gig. We used two 1 gigs, which were more than enough for us. VPC peering, we discussed it, but here's a diagram that makes it clearer, where you have the two AWS accounts in this case, two VPCs, a security group, and VPCs naturally, and you have the peering between them. This enables you the ability to send traffic back and forth. Okay, quite a simple example, but notice it's cross account, which is cool. Endpoints, we discussed those as well. I use the S3 endpoint. This is how it looks like. You have an AWS region, you have an AWS VPC, private subnet number 1, private subnet number 2, a router in between, or route table, internet gateway that will enable access to the internet, and a VPC endpoint to your S3 bucket, which again is inside the region. There's no access to the S3 to the public internet. Quite useful in terms of security and EMR transformation modeling and so on and so forth. VPN example, your site-to-site service. Again, customer network with a customer gateway, which is essentially your firewall. The VPN connection, where you create a VPN private gateway in AWS, it's about 10 minutes to set it up. Quite simple. You can do it even without the support team. It's next, more or less. You get a redundant connection. You get a set of instructions per the firewall you need. You give it to your firewall admin, assuming it's not you. You can do it either via CLI or CLI or GUI. Quite simple. 20 minutes later, you can work with that. There's no questions. Everything's clear. Great. Private and public subnet. This is my favorite scenarios of VPCs. Yeah, I provided even the link for the AWS blog on it. It's quite detailed and it's quite good. This basically, if you did this on your own and created your custom VPC, you are guaranteed to understand VPC inside out. This is the 2-3 days we discussed with the headache. Yes, good headache, but this covers basically everything. You get your region, your VPC, your private subnet with the 10.0.1 and the subnet mask, and you have a public subnet which gets the private subnet and the elastic IPs. As you can see here, the 198.51. You got a route table and an internet gateway. I see now that I didn't cover the NAT gateways, so there's an option to use NAT gateways as well. I don't think I covered it, but it's also here. You can use it. Here's the NAT gateway, sorry. Okay, you can see the NAT gateway in the public subnet. You can see it makes sense because the NAT gateway requires a public IP. So all these private subnets go through the router to the NAT and then go outside. Yes? It took me a while to understand this. This is one of the headaches, but I finally got there.
The main trick in that gateway is that the NAT gateway actually needs a routing gateway with internet gateway, so it will be able to access to the internet.
Yes.
Most of the time, this is the thing that most of the people don't understand why it's not working.
Yes. So a good comment from the background. Your name is? Avi. He said that the main thing about NAT gateways and internet gateways that they don't understand that a NAT gateway requires a a route through the internet gateway to the public internet. Have I reiterated correctly? Thank you very much. Again, as I said, I'm not an expert, network expert, just to show you the options and a high-level understanding matter.
This is is this a model that you are using?
This is what I'm using. I did it simply because it was required and it was a good match for our use case. We needed data in the private subnet, and then we needed to expose some front ends over here, and it needed some connection between them. And some of this was for users, some of this was for internal use, and so on and so forth. I even did some tricky stuff like putting the EMR over here, the Hadoop over here, and the load balancer over here that enables the front end through the load balancer outside. So this way I don't need to give them the key of the EMR server, so they don't have to do.
You are separating
The network.
Database
Yes,
from
into
the
different
board,
networks.
and they have to go through the.
But I did it even internally. I didn't give my data scientist team access to the servers,
Yeah.
only through the GUI and through the public, like an outside user. I treated them like hostile in terms of security. This is another good example which I tried to implement. It's a trickier one. It's with VPC. It's a private subnet without the public subnet, and a VPN connection to your site. The thing here to manage here is the DNS resolving. If you need to resolve DNS of a server over here from your local network, I wouldn't say good luck with that, but you need to understand a bit more than the basics. Yes, you have AWS. Yes, they will help you. Yes, there's good blogs over here that will help you go through it. Yes, you can do OpenVPN, which is a client VPN to connect here and then continue. You can do a lot of things, but it gets trickier. That's all I'm going to say about this. We can discuss this later. I rolled back this solution because I couldn't get a full grip over the network, so I wanted to do it on a new VPC and do some heavy duty testing before I implement this, but we are going to do this in terms of future work. The idea here is not that I didn't use private network. I used private network. I just wanted to avoid the use of public subnet entirely. Okay? Storage layer. So data governance in terms of storage layer. One of the coolest features or platforms or services in AWS, from my experience after doing heavy duty reading and lifting is all these features in S3. S3 is a storage layer. I took it for granted, I didn't ask, but then when I was compelled to check it for regulation and compliance, I found out that all the data is replicated on a multi-AZ layer. It means you don't have to worry too much about redundancy. Yes, you can do DR, which is highly recommended, but it's simply a matter of business cost versus risk. Do disaster recovery, DR. Thank you for the comment. A quick note about DR, if we discuss this. If you choose to do DR, consider doing DR on a different region for disaster, not for high availability, and a different account, which is separated from the rest of their accounts. So this account will be simply for DR purposes. So nobody has access, nobody accesses it, nobody uses it. So if anybody accesses it, you get an alert via Cloud Health or whatever you are using, and you know something is wrong. Questions? Yes, we.
You could use cloud formation.
Cloud formation.
Yeah, or in the same account or another account. You are saying going to a different account because of security issues.
We stated that you could say use cloud formation either in the same account or a different account. I'm not talking about the resources. I'm not talking about your EMR, your Redshift. I'm talking about the data. If you did a snapshot of a Redshift and you kept it in S3, and God forbid three rockets hit 3 AZs in Ireland, all your data is kaput. So all your data is in a different account and region. That's it. That's all I said.
I quite don't understand why a different account. It's on a different region.
Different account. Yes, you can do it in another region, and you can use CloudFormation to quickly build up your entire infrastructure. The thing about using a different account is to have a more fine-grained control over who uses this account, who has access to it. Yes, you can do it in one account. It's better practice in terms of blast radius. So if your primary account was hacked, all your snapshots were overwritten, your DR account protected because only 2 people have access to it. In terms of minimum to, the root account holders. The rest don't have access to it, shouldn't have any. You just expose a bucket for write-only, list privileges, and be done with it. No other policies is required. You don't need the ls, you don't need the read, you don't need the delete. Okay? So thank you for that. Challenge me. Do that. I will change the name so they don't know it's you. Versioning. If you have some sensitive data that you're afraid that will be deleted, one of the things you can do is enable versioning. If you don't delete it, no version will happen. If you do delete it, it will be deleted, but a version will be kept. So it's another trick to do some data protection, let's call it. Okay, we're in terms of data governance, then big data. Cross-region replication, we discussed about that. I have some more slides about that going on. Undeletable packet. I was challenged to create a IAM policy in terms of resource, in terms of S3 bucket, that creates a policy that nobody will ever be able to delete the bucket under no circumstances. And I succeeded. And then I got to a question, so now what? So I said, well, I got the task done. Nobody can delete it. But 2 years later, I needed to start cutting data. I forgot to put some lifecycle policy. Quick note about that later. And so I contacted support, and the only use case we discussed, root user can be applied, can be used, is to reverse this policy. So the root user can delete a policy of a bucket even if you put the deny policy put permission. Okay, what I did is don't delete, don't do anything, and I put specifically do not allow anyone to change this policy, which is a big balagan when you want to change something. And lifecycle policy. Assuming you do the don't delete policy, lifecycle policy it turns out is a backend service. It means it ignores the policy, and if you need to keep only 1 year, it will delete data. Keep that in mind. If you do a no delete policy, which one do you mean? Are you protecting it from users, accidental deletes, or you really don't want to delete anything? Cool trick I got from a nice security expert. You can do request and MFA authentication per delete request. So if the MFA is not applied in the last minute, you need to re-enter your MFA code to confirm your delete request.
Even on CLI?
I believe so. Didn't test it myself. But I believe the guy is good. Better than me. Another cool feature on S3, you can deny unencrypted data. So if you have by regulation the need to encrypt data, and you have a data scientist, data engineer that start writing data back to your S3 bucket, and you forgot to tell them, listen, encrypt your data, please. You have a policy on the bucket that enforces any file being written to S3 to be encrypted.
What do you mean? Is that different than actually defining the bucket to be encrypted?
Yes. You can say, well, 2 years ago there was no default option to encrypt everything that has been written, so you're correct. But if someone removes the option to encrypt by default, there's a policy that it's more strict to enforce each file must be encrypted, and you can specify the encryption, the specific encryption you want. Either it's server side, client side, or whatever, which is nice. You can be more loose and you say only you can allow any encryption method, which is also cool. Analytics, you have analytics on your S3 bucket. So if you want to know what was written, how much, and so on and so forth, cool feature, but it costs money. So take that into account. Not very expensive, but costs money. Good security concept, good to know. Generally speaking, while protecting data, you have to talk about 3 layers. One, in transit. That means anything that happens between your client and server, or the network, public, private, whatever. There's SSL, there's VPN, and there's all those options. At rest, that means everything that happens once the data has landed on the storage layer in AWS, which is either the local disk in your machines or S3. There are 2 primary layers, server-side encryption and client-side encryption. And in use is where you see the data in front of you as an analyst. It could be encryption in front of you, or encrypted in front of you, or it can be open. You can understand this is Moshe Chaim and his user number 777. So there are several ways. Either you can hash his name. Instead of Chaim Moshe, you will get A, B, C, D, E. You can do hashing with the key. Only a specific person knows the key, so it cannot be reverse engineered by the dictionary attack. You can do any encryption you can think of. There's a blog about security options in details I did. I don't want to go too deep into it, but there's a lot of options. It details all the server side and client side, either by S3 or KMS or whatever you choose. Each has its advantages and disadvantages. I will take the highlights, the most important things you wanted to keep in mind. One, there's a lot of options in terms of encryption to whatever degree of freedom you can think of. One thing to keep in mind is the resource-based policy versus identity-based, meaning it's much stronger to say this user has this specific permission to the bucket, and the bucket and from the other direction would state what it allows any entity to do. In terms of server-side encryption, S3 has a cool feature that enables you to do server-side encryption, which is totally managed by S3. So all you have to do is say, please encrypt, this is the checkbox, so on and so forth. There's the option to use server-side encryption with a key the customer provides, but you need to manage your key yourself, which is not very convenient, but it's useful when you have a use case where you want to avoid a scenario where, say, your data is in Virginia, and you want to avoid the scenario where Trump gets a federal, goes to Federal Bureau of Investigation and issues a warrant that says, give me all your disk, give me all your data. AWS have to comply with that, but you as an Israeli don't have to give him the key to decrypt the data. So it will work harder to get your data. I just took Trump as an example. I'm not anti anyone. Or this is in English, I'll be toast. CIA will be here tomorrow. Israeli, I love Trump, I love Trump. MSK, KMSK key. If you want to get one more sophisticated, you have a managed service that allows you to use KMS. It's not the default key that is used by your account. It's another key you generate. You can generate several keys. This is useful when you want to give the key to another account, and to save or share data between you two. You want to create this key for specific data source. For example, you have several data sources. Each data source you give them one key. You reduce the risk of blast radius when you have a breach. Additional trivial safeguards, VPN site-to-site to upload your data via VPN, or you can restrict to IP the access to a specific bucket. Identity is mainly about who and what you need to give him, for example, read-only. Resource-based policy, for example, would be deny delete request or deny encrypted. Again, another block here that did some further details. I will skip this because we're short in time. A basic diagram that covers everything. If you have a source data center and you want to send data, you need to create an identity-based policy. Here you have to use AWS user. You can't use roles, for example. My user, and it has access only to S3, only write-only, and you can give him a specific name bucket if you must, if you need. I did this, by the way, for the data sources. And then all the data in transit protection, you can do either client-side encryption, that even if the data is snatched somehow, it's encrypted on the client side, and HTTPS SSL or VPN. Then once the data is landed on S3, you have data at rest, which is resource-based policies, which is and encryption with doc, so you can do deny for everything you don't want. You can only accept data from the data center IP and so on and so forth. Availability layer. So as we discussed earlier, you have S3 buckets with data, and you can do cross-region replication from Europe to US and so on and so forth. Everything, all the data is encrypted in transit. A quick note about this: versioning must be applied, which is a bummer, but you put it because it's a requirement. You can do cross-account bucket policy. So you can put a policy on your bucket that allow or disallow access to a specific user in a different account. You have account A and B over here. You have cross-region and cross-account replication from a bucket to a bucket in a different region, which in another account. You have a walkthrough from AWS, very straightforward. The use case we used in Walla was for DR purposes. We created a DR account, which nobody has access except 2 people. You know why 2 people, by the way? Minimum.
One has the IAM name and the other has the IAM key.
Sorry?
One has the IAM username and the other has the IAM key.
This is one option. One have the IAM user and one have the key. The other one is
Redundancy of people.
if you,
Someone who dies, covering for people as well. You never know what can happen. Yeah. He leave the company or he died.
you're all very right. What happens if this person dies and so on and so forth? Actually, it's more complicated than that. You know what happens if you lose the root account credentials?
Contact the support and they
Contact the support and chaval. This is mainly the short case, in short for חפש את החברים שלך. A bummer. You need to go to a lawyer, you need to issue some papers that show you are who you say you are, and so on and so forth, signed by a notary, sent to AWS, wait for confirmation, and Allah is to, you may get your account back.
If you have a dedicated account.
Sorry?
Have a dedicated account manager, it's much easier.
If you have a dedicated account for?
Account manager
In AWS.
in AWS.
Yes, well, we had one. He specifically told us not to do so and to keep the MFAs for the root account by 2 people. And we kept the, even the key for the MFA in a safe vault, a physical safe vault. So in case 2 of us lose our phones in a yacht, we drop our phones. Okay, so this is why we do this. Big data security architecture level, more interesting stuff in terms of address and motion use. Well, basically, in a high-level approach, the entire ecosystem of the architecture, for each component, you have to discuss and defend your architecture in front of your CISO in terms of in transit, at rest, in motion. Sorry, in motion, at rest, in use. Okay? So you have to understand the different encryption options, and you have to understand the impact of using them. You can do restriction via identity and via role, and you can do restriction via resource. For example, for EMR, you have roles. You can give the specific EMR roles that allows specific actions on specific buckets. This was very good when we wanted to separate the teams, gave them separate options. Naturally, you have to manage your EC2 keys wisely. If you can avoid giving your team the EC2 keys, that would be great. You have to understand the differences between direct connect and public internet, security groups and knuckles, and consider Cloud1 with geolocation protection. Specifically on EMR security, you have the option to do security configuration in the web console, where you can specifically specifically state that you want all the data to be encrypted in transit, and some other options there. You have the option to use Kerberos. I think it's either available or going to be available soon in EMR as a service. All other webs inside EMR, for instance, Zeppelin, Hue and Uzi, you have to create SSL for it on your own. It's not done by default, it's used by a tunnel, but if you want to be very strict, you can apply SSL. We started working on connecting our Zeppelin to LDAP to avoid the brute force attack on our Zeppelin. We used Shiro and we gave it role-based access instead of a AWS user, which is in the documentation to use a user, and we thought it would be smarter to use all. We restricted per team the access to the S3 buckets, and we used per identity the least privilege, and then we found out the EMR read-only is not actually only read-only across the board. It has full permission, not full, but many permissions on the network layer. On the application layer, for example, you can do some security options on the user level, on table level, row level, column level, Kerberos, etc. Kerberos is the security between the nodes, if someone is not familiar with this. Privacy in a nutshell, PII, personal identifiable information. This is for you. It took me about 4 months to pronounce it correctly. I've been practicing. This is not a good lecture about it, but I will give you the key issues we dealt with in PII. We talked about PII with lawyers which are familiar with the use cases of data and protection and GDPR and so on. And they told us, at the end of the day, the following. The problem is, you have to assume your attacker has admin permissions to your system. And according to the lawyers, there's no such thing as anonymous database. If you have an anonymous database, and you take a third party, public, identifiable information database, and you join them together, in theory, that anonymous user you have can be reverse engineered into a real person, and that is a problem. Thus, if such a theoretical option exists, by default, in terms of legal eyes, your database is no longer anonymous. So have that in mind when you discuss with your team, company about PII. The solution is to wait for it, obfuscate and aggregate your data. This means, in a nutshell, if you have many raw data about specific user, for example, location history, don't keep a record of where he's been in every minute of his life for the last 7 years. Aggregate it. In the last day, he has been home and work. But you need to go even more than that and obfuscate the data by saying the following. This user has been in grid 777. Well, somewhere not attached to your system, you have a mapping of your grid and the actual coordinates or ID. So instead of saying neighborhood, instead of saying the address of home address, say Ramat Aviv neighborhood. This is good enough in terms of obfuscation because it's not a specific person, it could be a building or an entire group of people. The idea, if you come to think of it, that if you kept location history of a specific ID, anonymous ID user, or say 1 month, in theory you can reverse engineer or understand who this person is based on social media, which is a problem. But go argue with Google or the lawyers. In terms of raw data, keep only what you need. What you don't need, naturally it's not our decision, but always recommend that as an option. Usability and fine-grained access control. This is the most complicated part of the lecture. Roy also mentioned it. I will try to cover this as clear as I can and avoid the technical terms as much as I can, so the concept will be clear. Try to get the concept for me. Take a simple AWS example architecture in one account. Nothing sophisticated. I just dropped some drawing diagrams. You have regions, you have VPCs, You have maybe some endpoints, maybe some peering. Very cool example. Great. What happens if your security CISO says, take it one level up? So you talk to AWS and they recommend doing something called account segregation. The motivation behind this is fine grain over your access control, who accesses what, where, why, and so on. Fine grain billing control, which is a good advantage, like we stated, a specific project, something new, specific budget, keep it low, go ahead. And limit your blast radius. What happens if your account gets hacked? For example, as we discussed, the DR account.
Sorry, what do you mean by billing control?
When you create an account, say you have several apps, and you go to the billing of this account, what you get? The aggregated amount for everything, yes? S3, all the S3. RDS, all the RDS. EMR, all the EMR. So it's very hard to understand. You have a huge account with many services. What are you paying for? When you segregate the accounts, you can create an account per app. And you know. For example, I'll show many examples. You choose whatever works for you. But if per post or per whatever, okay? And then you get the billing specifically for this, what you planned. So here's a simple access control in one VPC. We are using it in the big data project of Walla called BU. You have a data source from anywhere in the world. Doesn't matter if it's streaming, batch, whatever. For now, it has write-only permissions to S3 raw buckets. Notice the Mikra here. How do you say legend in English? This team has a read-only access, or this cluster has read-only access for this. This does the transformation. It has read-write access to all other buckets except the transformation, the modeling. And it takes the data from here, transform it, put it in another bucket. And this cluster can read only from here and write only to here. So this is some access control in the same VPC. So let's go back to account segregation. A simple account segregation, the simplest use case would be business units. You have pre-sale team, BI team, and the admin. Say they are distributed all over the world. You create an organization, and inside the organization, your first account would be only users account, dedicated AWS account for users only, for the sole purpose of logging into the account. Okay? Once they log in, the assume role, which is a technical issue, we will not discuss how, they assume role to another account, which gives them temporary permission to do something in this specific account. It could be a different permission over here. In this example, what I drew is that the pre-sale guys only have access to their business unit. The orange BI team in the color orange has access only to the orange BU unit, and the admin has access by the green color to all the business units, which is kind of neat. And what happens is, even if you get a malicious attack over here, even if it's in the admin user, in the worst possible scenario, in any given moment, it can be only in one account, not in all the three. So if you catch this on time, you can respond automatically and automatically shut down the rest of the accounts, or in terms of access for those specific user. Complicated, very out there, very machine, but doable. Account segregation for geolocation. One of the meetup members discussed with me with the restriction he has that he has 50 data centers. He cannot remove the data from the country. That means he has to do the transformation and modeling locally in this specific country, which is kharbana, as you say. So I suggested he could have a look at account segregation per region. So if you have New York, you have US. If you have London, you have EU. If you have admin, create a DR account where you can do. Yeah. Okay. Fine-grained access control via account segregation. This is based on what we did in Walla. We did account segregation in Walla for each application in the production. We created an account. For example, Walla Mail, Walla Web, which is all the news you see, and Walla Friends, which is the identities. Since the identities of the users of Walla is מאגר מידע רשום, registered database of users protected by law and regulations and compliance, whatever. So we had to protect it so nobody has access to the Friends account except for DevOps and the admin of the database. So this was a good example. So based on that, I created this architecture for the big data team. We created account for the transformation inbound, the data modeling and obfuscation, outbound transformation and account per data source, if you must. We don't always have to. Production account and DR account. And we did the separation of data engineers, data scientists, and DevOps. The flow about this fine-grained access. The idea is as follows. You have encrypted PII data plus user ID, and you create a raw data account 1. So you send the data from your supplier number 1 to here, supplier number 2 to here, each get their own restriction policies and so on and so forth, do their transformation, and only the modeling account has read-only access to here, and the outbound transformation has only accept data via write, and the production only via read from here. So this makes it more sophisticated and much harder for an attacker. I'm not saying it's impossible, I'm sure it's possible, but the idea was to protect blast radius in terms of data. So if one data source is compromised, not the entire thing is compromised. So if we take the original architecture, we started in the beginning of layers, 4 layers. On the account segregation, we have the S3 buckets in the same account, and we create the network connections via peering for whatever we need. Takeaway messages. If you start a new big data project from the ground up, don't forget about the network. You have many options. It's very easy to get it right on the beginning, a bit harder to do it later on. Design your data access layer carefully. Who gets access? How you treat your data. Keep DR in mind. On the transformation, on the inbound and the outbound side, on the hashing level modeling. And the architecture impact in terms of security for each component at rest, in motion, in use. Keep in mind identity-based policy, resource, and account aggregation to avoid blast radius. Basically, this is it. Thank you very much, everybody. If you have any questions, now is the time.
Thank you very much.
Thank you very much.